All right, so it's time to do a little graphing of exponential functions. We're going to be talking about the multiplier for exponential growth and decay. That'll be pretty awesome as well. And we're going to write and evaluate some exponential expressions to model growth and decay situations. This sounds like a fun-filled lesson. Doesn't it, Mr. Grabner?
Awesome.
All right, so we've got something we want to graph here. It's y equals 2 to the x. And we've given you some x values to start off with. So those are going to be our x values. And we want to find our y values. And actually, I'm going to write the y over here. We're going to use that middle column for some work. All right? Work, 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 work. All right. So if x is going to be negative 3, I basically have 2 to the negative third power. And that's going to give me, well, 2 to the third is 8, so 2 to the negative third is 1 over 8. Then I can do 2 to the negative second. Well, 2 to the second is 4, so 2 to the negative second is 1 over 4. See how that works? We don't get negative numbers from negative powers. We get a reciprocal happen there, you know? And then we have 2 to the negative first. And I'm going to go ahead and just write them all in now. All righty. So remember, anything to the 0 power is going to be 1. That's what's going on in that middle one there. I think that's the only one that might throw you guys. But otherwise, you got 2 to the first, 2 to the second, 2 to the third. All right, so really we've got our ordered pairs here. Here's our x coordinates, here's our y coordinates. And we can plot each one of these. And with those fractions, just do the best you can in plotting them. All righty, so I've got negative 3 and 1/8, so we're somewhere right around here, pretty close to the 0. We got 1/4 for negative 2. And we got 1/2 for the negative 1. And then for, let's see here, 0, we've got 1, and so on and so forth. So there's all of our points, and we're going to go ahead and connect the dots. Now, we're going to talk about this in a sec here, but make sure you don't cross the x-axis in this one. So it continues to get more and more vertical, and it does have arrows on each end, unlike the radicals that we were just dealing with in the last chapter. So we do have arrows on each end, and you do want to do your best to hit all those dots you plotted. It's sometimes a little tough on the iPad, as you can see with the color mine, but it's getting more and more vertical as we go up this way, and it's getting more and more horizontal as we go this way. It never really truly gets completely vertical or completely horizontal, but it just gets really, really, really super, super duper close. So what we actually have here is a horizontal asymptote, and we're going to ask you about those, what your horizontal asymptote is. Well, my horizontal asymptote of this one is y equals 0. It's never going to go below 0. And let's think about why. Well, if I'm raising 2 to an exponent, x, no matter what, it's never going to be negative. No matter what I plug in for x in this one, it'll never make it a negative number. It'll just keep giving me a fraction, 1 over something. And that something that it's over is going to keep on getting bigger. So as you have like 1 over 100 and 1 over a million, you're getting super close to 0, but you're never going to actually touch it. And that's what an asymptote is. It just gets really close to that asymptote, but never touches it. And that would be why, because it never actually can, because you can never get this to equal 0, or a negative number. It can just get super duper close. All right? So that's something that we're going to ask you about. And what's our y-intercept? Well, our y-intercept is going to be where x is 0, so that way it lands on our y-axis, so my y-intercept is 1 in this case. That's a fun fact right there.